At the left side, you have the frequency of occurrence of each of the causes, and at the right side, you have the cumulative percentage that you have calculated here. So what you are going to plot is the causes at the bottom, the count or the frequency at the left side of the graph, with the number designating the height of each of the bar. Then the cumulative percentage, this would be represented ultimately by the line that is telling you the percentage of 2050. Okay. So once you do this, once you develop the Pareto chart, this is one illustration, but the other part is this scale, ሙሉ ስኬል ይረዝማል። ይሄ ሙሉ ስኬል የሚረዝመው ምንድነው? ከዚህ cumulative ጋር እኩል የሆነ height እንዲኖረው። ስለዚህ this line would start from the top. ከዚህ top ጀምሮ ሊይዝ ይችላል ማለት ነው። We'll look at an example later on. እዚህም አሳሳሪ designate የሚያደርግ ማለት ነው። But you can come across this type of illustration as well. Now, what is the interpretation of this graph? That is the point. Now, when you look at this, where would you find almost 80% of the cumulative effect? And like ተባብረው ብዙ effect የሚያመጡት የትኞቹ ናቸው? So here you can identify the one that is more closer to 80%. Now, this is the 80%. So you have either this or either this one. But again, the principle is that you want to find few number of defects to concentrate upon. So rather than considering an effect beyond 80%, you just find a defect which is just closer to the 80%. So when you look at this, 1, 2, 3, 4 of the causes are causing almost 70-something% of the effect. So you could go to the table to the previous table. Then you can see 1, 2, 3, 4 of the causes. These 4 causes are resulting 76% of the cumulative effect. So normally, when you look at the percentage, here you are considering 50% of the effect. Sorry, 50% of the cause. By focusing on 50% of the cause, you'd be addressing 76% of the effect. So, food preparation for 20%, quality of service for 24%, cleanliness for 50%, and overall taste for 12% could be eliminated if you just focus on this one. So, the overall effect would be 76%. ስለዚህ ምንድነው? 8 ላይ ሰርታችሁ 8 ናቸው ችግሮች። 8ቱ ችግሮች ላይ ሰርታችሁ 100% ለማጥፋት ከምትጥሩ 8ቱም ላይ ነው የምትሰሩት። ስለዚህ ኢነርጂያችሁ ኤፈርታችሁ 8 ቦታ ይከፋፈላል። 8 ቦታ ተከፋፍሎ 100% ከምታገኙና አራቱ ላይ በደንብ ሰርታችሁ 76% ነው ይለኛል። So this is the principle. Prioritize and identify areas to focus upon and justify why. Now here, just by focusing on 4 items, which are 50% of the cause, then we can eliminate 76% or almost 80% of customer dissatisfaction would be avoided. So that is why we use Pareto analysis, in order to identify areas of focus for our operation. Now, this is what I told you about the representation of the Pareto diagram. ቅድም ላይ ያሳየኋችሁ ከታች ከመነሳት ይልቅ ይህን ፐርሰንቴጅ ስኬሉን ካሰፋ ነው then you could see this. እዚህ ጋር ያሏችሁን የዚህን cumulative ድምሩን እና ይሄ 100% የሚለውን approximate ካደረጋችሁት እኩል level ላይ እንዲገኙ ካደረጋችሁ then you can see that you have this type of representation. Now here, there are certain defects in a process. For example, here you have over shelf life, shelf life expire or ያለፈበት ማለት ነው። excessive additive ያለበት ሴፍቲ ሌቭል የሌለበት ፓኬጂንግ ትክክል ያልሆነ ወይ ደግሞ ሌሎች ኤክሰሲቭ ባክቴሪያ pesticide residuals raw material defect so all these things are included are identified as problematic እነዚህን ፍሪኩዌንሲያቸውን ይዘን እነዚህ ይሄ ፍሪኩዌንሲ ነው የሚያሳየን then cumulative ደግሞ እዚህ ጋር አስቀምጠን so for example here you could identify the one that's closer to 78% or 80% Pareto principle እንከተላለታለን ማለት ነው so you could focus on these 4 defects and eliminate 78% of the sometimes when you have a resource scarcity then you might be even more focused ያን Pareto 80-20 million strictly መከተል ሳይሆን you might say that we just focus on two of the problems or the cause for the problem and identify and eliminate 78% or 50 by just focusing on these two you can say that you can eliminate 57% of the defect the effect of the problems on our performance so when you just focus on two of the items out of these 8 so that would be 2 divided by 8 so this would be 25% so you are focusing on 25% of the causes እነዚህ ሁለቱ ማለት ነው ሁለቱ ላይ ብቻ እንሰራለን ብሎ you are focusing on 25% of the causes but this would result on elimination of 57% of the effect እዚህ የምግብ ዲፌክት ስለሆነ እዚህ ሁለቱ ላይ ብቻ ብንሰራ ኦቨር ሼልፍ ላይፍ ያላቸውና ኤክሰሲቭ አዲቲቭን ለማስቀረት ብንሰራ we are focusing on only 25% of the causes but the ultimate result would be more than 50% እዚህ ይሄን ማይንድ ሴት ለመፍጠር ነው ፓሬቶ አናሊሲስ የሚሰራው ማለት ነው identifying the critical few now these two would be the critical few የምንላቸው ሁለቱን ይሆናሉ ማለት ነው whereas the rest they are known as the trivial many ቅድም ባነሳነው ላይ ማለት ነው trivial many እና vital few ብለናል so once you conduct this analysis you can identify that these few or two of the items are vital whereas these ones are trivial that could somehow not now the last tool that we are going to see in this chapter is the scatter diagram I think most of you have covered statistical analysis or statistics you have revised statistics for your various courses last year so you'll not be new to the principle of scatter diagram it's just correlation analysis correlation between two things so the scatter diagram it's a two-dimensional plot x and y and normally what we do is that we make y a dependent variable okay if it is a dependent variable we expect it to change as we change the other variable x which is the independent variable ይሄ independent variable በራሱ የሚቀያየር or በፕሮሰስ የሚቀያየር ነገር ግን የዚህ መቀያየር yን ኢንፍሉዌንስ ያደርገዋል x በራሱ ምክንያት ይቀያየራል y ግን x ስለተቀየረ ነው የሚቀየረው so we assume this and plot these 2 points in a single graph so scatter plots are useful for finding direct or indirect relationship and this relationship is designated or articulated as correlation of the two variables x and y and this would help us analyze the dependency of quality issues within the two variables relation so to identify the correlation that might exist between a quality characteristics and the factor that might be driving it with correlation analysis so we have two things we have one quality characteristics that you want to investigate for example you want to see the influence of length. You have certain plastic material, and you say that the length of that plastic material is influenced by temperature. So the length is the quality characteristics that you want to investigate, and the factor would be the temperature. So as we increase the temperature, what would happen to that length quality characteristics? So we want to investigate this. ስለዚህ ምንድን ነው ማድረግ ያለብን? ከምን ድረስ ነው ቶለሬት ማድረግ እስከምን ድረስ አክሴፕተብል የሆነ ቼንጅ አለን? ከዛ በኋላ ያለውን ቼንጅ በምን መልኩ ነው አንደርስታንድ የምናደርገው የምንጠቀምበት የሚለውን ሊያሳየን ይችላል ማለት ነው። So the two variables, the two-dimensional xy plot is going to be developed by two variables, x and y. The two variables could be critical to quality characteristics and a factor, as we said previously, and quality characteristics እና እሱን ኢንፍሉዌንስ የሚያደርገው ፋክተር or ያደርገዋል ብለን ያሰብነው ወይ ደግሞ ሪሌሽኑን አናውቅም። አንድ ኳሊቲ ካራክተሪስቲክስ እና ይሄ ፋክተር ምን አይነት ሪሌሽን እንዳላቸው አናውቅም። ስለዚህ ማወቅ ስንፈልግ ልንጠቀምበት እንችላለን። for example length እዚህ ጋር length ብለን አውርተናል. and the other quality characteristics might be vibration. length እና vibration ምን አይነት ሪሌሽን አላቸው? length of the plastic, length of temperature አይተናል። on temperature አይተናል። length on vibration might be one thing that we want to investigate. ስለዚህ በትክክል አፌክት ያደርገዋል የሚለውን አንደርስታንድ ልናደርግ ያስችለናል ማለት ነው። or you might consider two factors affecting a critical equality character. እዚህ ጋር ምን አለን? መጀመሪያ length እና temperature ብለን ነበር አይደል? length versus temperature ብለን ነበር። length versus vibration ብለን ነበር። you might consider vibration against temperature. ሁለቱን ልናጠና እንችላለን። ምክንያቱም ሁለቱም length ላይ ምን አይነት ኢፌክት እንዳላቸው ለየብቻ አይተናል። ከዛ ደግሞ የሁለቱስ ሪሌሽን ለምሳሌ length እና vibration ለየብቻ ካየናቸው ምንም አይነት ኢፌክት የላቸውም ብንል length እና temperature ግን strong relationship አላቸው። strong positive relationship አላቸው ብንል ይችላል። ሁለቱስ ምን አይነት ሪሌሽን አለ? temperature እና vibration. temperature ሲጨምር vibration ሲጨምር temperature የሚጨምር ከሆነ እዚህ ጋር ዳይሬክትሊ ሪሌሽን የለውም ብንልም ግን በኋላ ላይ vibration ስንጨምር temperature ጨመረ፣ temperature ስለጨመረ length ጨመረ። ስለዚህ ኢፌክቱን ዳይሬክት ከምናየው በጃዙርም እንድናየው ያስችለናል ማለት ነው። So you might consider the relationship between two factors that are affecting the same quality characteristics, or you may consider analyzing two related quality characteristics. For example, length and weight. lengthን ከweight ጋር ያወዳደርን ነው በተለያዩ ፓራሜትሮች ወይ በተለያዩ ኦፕሬሽናል ሴትአፖች። Normally, in simple sense, scatter diagram is describing relationship between two variables. That's it. It doesn't matter what type of variables they are. Either they are factors influencing something or they are things that we want to monitor, like critical to quality characteristics. So how to construct this diagram? Decide which paired factors you want to examine, which are the two variables that you want to study, and make sure that they are measurable. Sure. ለምሳሌ length እና smell ብትሉ compare ልታደርጓቸው because you cannot really measure smell. That is very important. The two variables need to be measurable on a continuous scale, and you have to collect sufficient amount of data, usually in order to represent the relationship in greater detail. It is recommended to use 30 to 100 pair of data points. ትንሽ ሲሆን በትክክል ላይገልጽላችሁ ይችላል። So it is recommended that you use this much paired points. Then find the highest and the lowest value of both variables because they would determine the scale. X እና Y ስንል X ምን ያህል በምን ያህል ይከፋፈል y በምን ያህል ይከፋፈል የሚለው ማወቅ ስላለብን so you need to find the highest and the lowest values of the variable. Then based on that scale, based on this measurement of the length of each of the axes, then construct the vertical and the horizontal axis. Then you just plot the data. This is very simple. እያንዳንዱ point x የሆነ value ሲሆን y ምን ሆነ እያላችሁ plot እያደረጋችሁ መሄድ ማለት ነው. So the data that you collect needs to be in pairs. That means data collection poinታችሁ 1 2 3 4 እያላችሁ ትሄዱ ትችላላችሁ. You have x and you have y. So አንደኛው data collectionናችሁ ላይ x ምን ሆነ x1 ሲሆን y ስንት ነበር y1 ምን ነበር x2 ሲሆን y2 ስንት ነበር and so on. ስለዚህ እያንዳንዱ ፖይንት በእነዚህ ሁለት ፖይንቶች ነው ዴዚግኔት የሚደረገው። የመጀመሪያው ፖይንት x1 y1 ሊሆን ይገባል ማለት ነው። ምናልባት እዚህ ጋር ስንመጣ ደግሞ የተለየ እያንዳንዷ in pairs ነው ኮሌክት መደረግ ያለበት in order to develop a scatter diagram. Then when you plot it, ይሄን data point plot ስታደርጓቸው 30 or ከ30 እስከ 100 ያለውን plot ስታደርጉ ምን አይነት behavior ሰጣችሁ? Now if all the points are closer to each other in certain pattern, for example, if you could approximate the data points with a single straight line, then we call that to have a strong relationship. Here and with the ተሰመረው line, ይሄ line approximation ነው። normally data point አይደለም እሺ data pointዎቹ ቀያዮቹ ናቸው። You have these data points. If you can approximate a line that would touch almost all the points, we say that it has a strong relation. እሺ ሁለቱም ጋር ስታዩ strong ናቸው ምክንያቱም ዴታ ፖይንቶቹ በጣም ለዚህ ላይን የቀረቡ ናቸው። Now as one increases, if the other also increases, x በጨመረ ቁጥር የy ፖይንቶችም እየጨመሩ ነው ማለት ነው። እንደዛ ከሆነ we call it positive relation. አንዱ ሲጨምር ሌላውም እየጨመረ ይመጣል የሚል implication ስላለ አንደኛው ሲጨምር ከዚህኛው ሆነ ይሄኛው ለምሳሌ x እየጨመረን ስንመጣ y እየቀነሰ ነው እየመጣው እዚህ ጋር ስታዩት ቺን ፖይንት ስታዩ አሁን ለምሳሌ x has a lower value whereas y has highest value እዚህ ጋር ስትመጡ ግን x ጨምሯል ከዚህ ወደዚህ ጨምሯል y ምን ሆነ ስንል ከዚህ ወደ ታች ወርዷል ከፍ ካለው ነጥብ ወደ ታች ወርዷል so when you increase one if the other decreases then we say it is a negative correlation. Now the other thing is if the points are not really closer, if they are somehow close but they are not really well condensated to the approximation line like this, then we call it a weak correlation. Again, positive negative applies here as well. Sometimes if they are moderate በጣም አልተጠቀጠቁም እንደዚህ በጣም አልተጠጋጉም በጣም አልተራራቁም then we call it moderate correlation. moderate positive or negative again. ፖይንቶቹ ምንም አይነት ሪሌሽን ከሌላቸው ለምሳሌ ይሄን ነጥብ ስትወስዱ ይሄ y የሆነ ፖይንት ላይ ነው ያለው x ትንሽ ነው y moderate በኋላ ሄዳችሁ እዚህ ጋር x በጣም ጨምሯል x ይሄን ያህል ጨምሯል y ምን ሆነ ስትሉ በጣም ኢንሲግኒፊካንት የሆነ ዲክሪዝ አለ እንደገና ሌላ ቫልዩ ስታዩ ደግሞ እዚህ ጋር x ትንሽ ነው እዚህ ጋር ስትመጡ y ትልቅም ማለት x ጨምሯል y ግን እጅግ በጣም ጨምሯል so there is no relation between the two variables አንዱ ሲጨምር አንዱ እንደፈለገ ሊጨምርም ሊቀንስ so in this case we say that there is no relation and sometimes አንዳንድ ጊዜ ደግሞ ምን አይነት ሊያጋጥማችሁ ይችላል ለምሳሌ ሪሌሽናቸው የምቀደም የሙቀትና ሌንግዝ ያልኳቸው የፕላስቲኩ እንደዚህ አይነት ሪሌሽን ሊኖራቸው ይችላል። መጀመሪያ ላይ ትንሽ ይሄ ትንሽ ሲጨምር ይሄም ትንሽ እያለ ይሄድና ከሆነ ፖይንት በኋላ በጣም ፒክ ያደርጋል። in that case we call them complex relationship። ለምሳሌ ወይ ደግሞ ፓራቦሊክ የሆነ ሪሌሽንሺፕ ሊኖራቸው ይችላል። ከተወሰነ ስቴጅ ይጨምራል ተወሰነ ስቴጅ ላይ ኒውትራላይዝ ያደርግና እንደገና ደግሞ ይቀንሳል ሪሌሽንሺፕ። ስለዚህ ዴታ ፖይንቱ እንደዚህ ፕሎት የተደረገ ከሆነ then we call it a complex relationship። as such direct correlation አላቸው ሳይሆን complex relationship አላቸው ብለን designate ልናደርጋቸው እንችላለን ማለት ነው። and the correlation analysis normally between the two pairs have two pairs data x and y. So the correlation between x and y could be analyzed using correlation coefficient R. And the correlation coefficient R is calculated by this formula. You identify the mean value of x ቅድም ዚጋ ኮሌክት ያደረጋችሁትን mean value x ባርን ዚጋ ታገኛላችሁ። የዚህን mean value ደግሞ y ባርን ታገኛላችሁ። Then you use this x bar and y bar values and each of the observations. ዚጋ ደግሞ x y ያለን ወሰናቸው ማለት ነው። Then you sum them up together and then divide them by the square root of the squared summation of each of the difference between the values and the mean value, and that would give you the correlation value. And correlation value normally R would be between 0 and it would be the correlation value would be between -1 and 1. Remember, minus የምንለው ለኔጌቲቭ ሪሌሽንሺፖች እነዚህ በሙሉ ኔጌቲቭ ሪሌሽን ያላቸውን would represent them by negative, whereas those positive relationships they are designated with positive values. Now በዚህ ውስጥ ግን የተለያየ ክፍልፋይ አለ። ኒውትራል የሚሆነው 0 ነው, and neutral would be telling us no relation. ስለዚህ ከ0 እስከ 1 ወይ ደግሞ ከኔጌቲቭ 1 እስከ 0 ያለው ውስጥ ያሉት ቫልዩዎች strong, weak and moderate ተብለው ይከፋፈላሉ ማለት ነው። If it is 1 then we call it strong. If it is different authors suggest different alternatives, but if it is greater than 0.7 we usually say that it is strong, 0.8 or 0.7. If it is between 0.5 and 0.7 or 0.8 then we call it a moderate correlation. If it is between 0.3 and 0.5 then we call it a weak relation. If it is between 0 and 0.2 or 0.3 then we call it we say that the relationship is insignificant or no relation. So this is an example. We have pizza production and በስንት ሰዓት ብናበስለው ምን ያህል ዲፌክቲቭ ፓዮችን እናወጣለን ነው ፒዛ እናወጣለን ነው። ካልበሰለም ዲፌክቲቭ ነው፣ በጣም ከበሰለም አሯል ዲፌክቲቭ። So what is the optimal cooking time could be analyzed like this. So ለ10 ደቂቃ ብናበስለው ለ45 ለ30 ለ75 ለ20 ለ25 እያለን የተለያዩ ሰዓቶችን ሞክረናል። በዛ ውስጥ ሳምፕል ወስደን ምን ያህል ዲፌክቲቭ ፓዮችን አገኘ። So the time, cooking time versus defective pie is the question. So you could plot these 2 points. So time is continuous and you can count these values as well. ስለዚህ ዲፌክቶቹ ስናያቸው ማክሲመም እዚህ ጋር ያለን 20 ነው። So you could increase it a bit. ስለዚህ ከዲፌክቲቭ ፓይ ከ0 ጀምሮ እስከ 20 ልንል እንችላለን፣ ግን ለጥሩ ኢሉስትሬሽን እስከ 25 ድረስ እንወስዳለን። So this is what we call the length of identifying the highest and the lowest value for determining the length of the axis. Then ይሄኛው cooking time ደግሞ ከ10 ጀምሮ እስከ 75 ድረስ አለ። So ይሄንንም ለኢሉስትሬሽን የተወሰነ ጨምረንበት ከ0 እስከ 80 ድረስ አስቀምጠናል። ስለዚህ ምን እየሆነ ነው የሚመጣው የሚለውን ለማየት እንችላለን ማለት ነው። So you can see that as you increase the time, then the defective pies would increase. And when you look at the values and use this correlation formula, you identify እነዚህን ደምራችሁ mean value, the defective pie mean value ማውጣት ትችላላችሁ. You could use that formula, and the correlation value that you'd obtain is 0.979. As you said, if the value is usually between 0.8 and 1, then we say it is strong. Okay, so our conclusion from this analysis is that in pie production, the cooking period or minute of cooking has strong relationship with defective units or defective pies that are produced. Okay, so easily ያላቸው relationship ማየት እንችላለን ማለት ነው። ለምሳሌ ደግሞ ኩኪንግ እዚህ ጋር ኩኪንግ ታይምን አይተናል። ምናልባት ሌላ ቫሪያብል ልናይ እንችላለን። ኩኪንግ ታይም ኤንድ ዶው ዌይት፣ የዶው ኦር የሊጡ ክብደትስ ምን ያህል፣ ከሊጡ ክብደትና ዲፌክቲቭ ፓይን ልናይ እንችላለን። የሊጡ ክብደትና የኩኪንግ ታይምን ሪሌሽንሺፕ ልናይ እንችላለን። ስለዚህ እንደዚህ አድርገን ሁለት ቫሪያብሎችን ያላቸው ሪሌሽንሺፕ easily understand ማድረግ እንችላለን ማለት ነው። So this is all about the second unit. If you have any question, ጥያቄ ካላችሁ